Okay, in Chapter 4, Section 4.2, we're going to look at some techniques for choosing predictors to include in your regression model. So let's say we have a data set that's got lots of potential predictor variables. We want to think about which ones should we include, how many would we need to include, what happens if we include quadratic terms and interaction terms and other functions. We could very easily and quickly come up with a massive model. So maybe it's tempting to put them all in since we'll increase the R² value. But remember, we're always looking to build a simple model that's going to be effective. So we need to balance. Okay, so the data set we're looking at that's in D2L is first year data, and that's in the Chapter 4 data set. And it contains measurements on 219 college students. And there's a number of variables that were measured. So they were trying to predict GPA after 1 year of college, potentially based on high school GPA, SAT verbal scores, SAT math scores, the sex of the student, etc., etc. So you can see here, I think there are 9 variables present. And if you remember back from your discrete math days, if we think about all the models that we could build to predict GPA based on 9 predictors, well, there would be 2 to the 9 possible models we could build. And that's 512 models we would need to consider. And that's not even with building in interaction terms or higher order terms. So that's a lot of models to sort of sort through. We want to think about, and I'm going to show you some techniques that can be used in Minitab to help make this process simpler. Okay, before we get going, this side-by-side sort of scatter plot is just showing how GPA relates to each of the quantitative variables. So you can maybe start to see, which variables does GPA have a positive or negative association, and where is it strong or weak. The next graph shows GPA versus each of the categorical possible predictor variables. And so again, you can take a look at this data and see, which variables might be helpful, categorical variables might be helpful in predicting GPA. So for now, we're not going to consider any interaction or higher order terms, so just try and keep it simple to begin with. Okay, so this section is all about variable selection, and really the goal is to find a model that isn't too big or too small, but is one like Goldilocks, just right. So there's 3 methods that can help you find a model that might be adequate. The first I'll show you is something called best subsets, and then we're going to use something either forward stepwise regression or backwards stepwards regression. Okay. So these again are going to be useful because we already have some tools in place to compare models. We could look at R² or R² adjusted. Okay, but again, we're going to need to sort through 512 models, and we'd like some help with that. Okay, so best subsets in Minitab does just what it says. It's going to give you a collection of models that are best in some sense. So it'll give you maybe 8 or 9 or 10 models that you'll have to decide which one to select that you want to use. Okay, so the way you have Minitab do this is just click on Stat Regression, where we've been, but then select Best Subsets. The second screen below will pop up, and in your response, you want to put the GPA, and then you want to put all the other predictors in here. So not GPA, but all the other 9 potential predictor variables are going to go in free predictors, and then just hit OK. Okay, and what you'll get is Minitab gives you is something that looks like this. So you can see it's given us a number of models. It gives us 2 models that have just 1 variable. So the first 2 are the best models that if you just want to include 1 predictor variable. So it's suggesting either to use high school GPA in this case, or in the second case, I think that was like humanities, the HU variable. And so you can compare R² and R² adjusted for them. So then it gives you the next 2 best models that have 2 predictors and then 3 predictors, and then down to the model that has 9 predictors. Okay, So again, I guess it's giving you about 17 models to consider. So what we might look at is find the model just to start off that has the highest R squared adjusted, which would be right here. And it also has a high R squared value. Okay. So that model you can see here includes 6 predictors, wherever the 6 X's are. So what we might want to do is just to run that model and then look at the individual t-test to see if all of the predictor variables are effective. And so if you do that in Minitab, what you should get is this output. And what you'll see then is the male variable and the SS variable are not significant. So you might ask, right, would a simpler model be as effective? Could you toss out those 2 variables and would it be just as, as effective? And you could do a nested F-test or that we've done in Chapter 3 to answer that question. Okay, so remember then, if we want to choose the best subsets, when we're looking at all that output I just showed you when we got the best subsets output, we know that we can look at R squared adjusted and we can look at R squared. Remember that R squared adjusted, it gives a penalty when unnecessary terms are added. Another statistic to look at is something called Mallow CP, and you should see that in that best subsets output that I just showed you. So it also adjusts for the number of terms you add to the model. And the goal is just to find the smallest CP that's closest to the number of coefficients in the model. Okay, I really strongly suggest that you carefully read pages 159 to 160 on the section on Mallow CP to get a little more insight and depth into this topic. Okay. But I will note before we move on that the model that we just selected for our best model had a CP of about 4.8. and it had 6 predictors in the model. Okay, and again, the goal is relatively, and the book explains why, you're really looking for a CP value that's pretty close to the number of coefficients in the model, and that does it. Our CP was about 5 with 6 predictors. Okay, 2 other methods to help you determine a adequate or a good model, efficient model, are called backwards and forward elimination. Okay, so the way back, we're going to just start off with backward elimination first. This is easy to use. So just think about this. What you do with backward elimination is you start with a full model. So you put, in our case, all 9 predictors into the model. And then what you look at is you look at the Minitab output and you find the term whose individual t-test gives the largest p-value. Okay, and if that p-value is bigger than a cutoff, let's say 5%, you toss out that variable. Okay. And if not, then you just stop. So then you iterate again and you keep looking at the next variable that has the highest p-value. If it's greater than 5%, you throw that out and you keep going until that's not the case anymore. So again, Minitab will do this for you. If you just go to regression, and then regression again, and then you'll fitted regression model where we've been many times. In the responses, put GPA, and in your predictors, put the 9 potential predictors, high school GPA down to college bound. And then click on stepwise, right here, right? Click on stepwise. All right, and then on this pop-up window that'll come up, you'll see it says none, but if you click on it, there's several options. We want to select backwards elimination, and I'll talk about forward elimination in a little bit, but it's right above it. So select backward elimination, and then the only other thing you need to adjust for is put your level of significance. So I'm using an alpha value of 0.05. I think 0.1 is default, but I'm doing 0.05. Okay, and then you just hit OK. All right, and then you'll get a bunch of Minitab output. So we should see here that we get, this is our based on backward selection, the best model should include high school GPA, SAT, verbal, HU, and white. And here are the individual coefficients. The weakest predictor is SAT verbal, but you can still see that it's significant. Its p-value is still below 5%. Okay. Turns out that this model has a CP value of, you can go back and look at the best subsets output, of 3.9. And it turns out that's the same CP value that we got using the best subsets model here. But again, that's just coincidence. Okay, finally, you can, another option, the third option in building your model is to look at forward selection results or forward elimination. And you'll still go to stat, regression, but instead of selecting backwards elimination, you'll now select forward elimination. So the way this works is it's the model that Minitab will start with no terms at all. It'll just find the single best predictor that has the highest R-squared value, and it puts it in the model and calculates its individual p-value. If the p-value is less than 5%, it keeps that predictor in the model. And then it keeps adding predictors in, the next one with the highest R-squared value, provided its p-value is less than 5%. And it keeps going until that's not the case. And in this case, you'll see that if you run this, a forward elimination technique gives the same best model that the backwards elimination gave. Okay, that's it for section 4.2.